As far as hydraulic modeling or design of any water network is concerned, we have two major software that we as water engineers will normally use to design any water network. The first one is EPANET and the second one is nothing but WaterGEMS. Unlike EPANET, which is free and open source, WaterGEMS is a commercial software. And even though under the hood, WaterGEMS uses EPANET algorithm or EPANET engine, WaterGEMS has more features and it is more advanced compared to EPANET, at least for now. We have been using EPANET for quite a while now, and I think it's time to cover WaterGEMS. So if you are new here, my name is Engineer Lodrick and this is Hydroinformatics Academy, a place where we discuss technologies related to water supply and irrigation. With that out of the way, let's get started. So this is the software that we are going to use, that is WaterGEMS Connect Edition. And before we do anything, the first thing that we need to do is to make sure that we have settings that we need for our project. Okay, so we are going to select Home, then select Options. Then this is a pop-up window that we are going to have. So we have like two options here. The first one is Steady State or EPS solver, and the other one is Transient solver. But for our case, we are going to deal with a steady state analysis. So what we need to do is to select this one, then we need to right click, then select the properties. This is the window that we are going to have, and what we need to do here is to select the friction method that we want to use. So if I click here, you can see like we have this drop down menu. So if I select this, you can see like we have like 4 friction methods that we can use for our analysis. But for our case, we are going to use Hazen-Williams. Okay, Hazen-Williams. And the next setting that we need to make sure that we set is calculation type. By default, it is hydraulics only. And for our case, we are not going to change anything here. So we are going to maintain hydraulics only. Apart from that, what we need to change is time analysis type. Okay, so we have like 2 options here: EPS or extended period simulation, and the other one is steady state. So for our case, we are going to select steady state. And the next option that you can set here is engine compatibility. And if I click this drop down menu, you can see we have these several options here: the EPANET 2 engine and also the WaterGEMS engine. So I'm going to stick with the default one, which is WaterGEMS. For now, everything is okay. So I'm going to close this window. The next setting that we need to set, actually even this one I'm going to close. So the next setting, I need to go to Tools. So from here, what I need to do is to click this area here. You can see it is written, if I hover my mouse, you can see it is written Options. So I'm going to select this one. Then this is the window that we are going to have. Okay, so we have like several options here, but the one that I am interested with is the units. So if I select units, you can see we have several options here, but the first unit that we need to change is to select the default unit system. For me, I want to use the SAI unit. So if you want to use empirical units, then you can change them from here. But for me, I'm going to maintain SAI units. And of course, here at the reset defaults, I'm going to make sure that I select also the SAI unit. So the first thing you need to change is at this area here. Then you go back and change at this area. So that is number 1. Number 2, we need to change units in this window. So if I go down, you can see like we have, so the only thing that I can change here, bulk reaction, no, just maintain the way it is. Also, let me go down and see if there is anything that I can change. Diameter, I want to display my diameter in a millimeter. So if you want to change like in feet, then this is where you can change. And also for larger diameter, you can change them from here. By default, it is in meters. So if you have large diameter, then you can set either you want to use the millimeters or the meters. So for me, I'm just going to maintain the default values. Also, if I go down, you can see the flow. So we have like two options here. So the first one is flow and the other one is flow small. So for flow, I want to use liters per second. So you can even go and change whatever unit that you want to use in this area. But for me, for flow, I want to use liters per second. And not just that, display precision, I want to use 2 decimal places, so I'll just put here 2. And also for small values of flow, or for small value of discharge, I want to use again the same units, which are liters per second. And also the display precision, the same too. So head, if you want to change, you can change the values here, but I want to maintain the way they are. And also if I go down here, you can see we have these several units here. For Hazen William, the roughness of course it is unitless, so there is nothing here I can change. If I go down, you can see, so these are the units that you can change as far as this window is concerned. So let me go and select labeling. Again, if there is anything that you want to change, you can change it from here, but for me, I'm going to maintain the way they are. So for now, I'll just click OK to make sure that I save all my settings. So that is the first step. So the next thing is to draw our actual network. Again, as I said, this is going to be a step-by-step beginner's guide. So we are going to use this first option. So I'll just show you the next option in the coming tutorial. So for now, let me go back here and select home, actually not home, the layout. You can see we have multiple elements here that we can use for our network. You can see here we have tank, reservoir, hydrant, junction, pipes, okay, customer meter, and all those tabs, okay. And also if I move here, you can see we have pumps. So for pumps, these are the options that we have, and for valves, we have these valves here. But for now, what we are interested in is this area here. Again, as I said, this is the first option that I'm going to show you. Or the next video, I'm going to show you how to use the second option. So for the first option, we are going to use this tab here. So we are going to start with our source. Our source is actually a reservoir. So I'm going to click this reservoir here and insert it here. Okay. And I'm going to select the first junction. So if I move my mouse here, you can see this is the junction. Okay, so the first junction, second junction, and the fourth junction. And also I need to add some others here. And also this one around this region. And again, this one I'm going to click here, then this one and this one. Now we have our source and the junction. So what we need to do is to add the pipes or the links. Okay, so just like what we did on Ethernet, on WaterGEMS we have the same approach. So the pipes, we use the links as the way to represent our pipes. So I'm going back here. You can see we have this area here. So if I click here, we have laterals and pipes. So I'm going to use the pipe. So if I click this, you can see now we have something here at our cursor. So if I want to take water from this reservoir to these areas here. So I'll just click this once and again this once. As you can see, we have our pipe just like that, and also this one. So from here I need to move at this area. Just make sure you click just once, not twice, then done. Again, I want to go back here and click once at this, on top of this node, and again I want to click here once. Then let me select this one. So from here I just click done. And also I'm going to select this J10, junction 10, and then click this one. Then from here, what you can do is to right click, then click done. But if you can see, this is the junction that I don't want to use. So how can I delete this? Is simple. Let me select this select option here. Okay, this select option, and if I highlight this, then I can just press delete. Simple as that. So the next thing that we need to do is to insert properties for links, junctions, and our source. Okay, because as of now we did not insert any link length or pipe length, no junctions data like elevation, so we need to insert those data from here. I'll just click the same select, and then we are going to start with our source, which is this reservoir here. I just double click it, then this window here is going to appear. So what I need to do is to find a way, or to find a place where I can insert my elevation. So if I go back, I move this, you can see we have here the physical properties. Okay, so the physical properties of this reservoir. So I'm going to double click this and open the physical. So if I click here the physical, you can see we have option and zones. For now, our interest is elevation. So our source is located at 90 meters above the sea level. So I'm just going to insert here 90 and then close. And again, I'm going to double click this junction. So the physical, then elevation properties. So the elevation here is 80. And also this one here, the elevation here is 75. And again, this one here, elevation here. So if I go to physical, then elevation here is 75. So let me double check. You can see 75. Yeah, and also this one, the same elevation value, which is 75. Okay, so the next junction is this one, which is J7. I need to double click it and insert the elevation value. Elevation value at this junction here is 70. And again, at J8, elevation here is 72. So elevation 72. Then I need to close this window. Then at this junction, which is J10, elevation here is 68 above mean sea level, and also this one here is 65. Also this one here, which is a J12, elevation here is 70. So as far as elevation data is concerned, we are done. So we need to also to specify the pipe length. Okay, so the link length of our model. So from here, what I can do is to double click this. You can see if I go back here at the physical, we have the pipe diameter, but also if I go down here, you can see we have here the C value and the option to insert the user defined lengths. By default, we have the scaled length value, but we don't want to use that because we have our own length. So from here, I'm going to select. So the question here is, has the user defined length? If it is yes, then you need to click this. Then you're going to specify as true. Okay, so we need to change this to true so as we can be able to insert our own length value. So from here, we have 200 meters. Okay, so from our source to this point, so this P4 has a length of 200. I'll just close this, so you don't even need to close. Okay, let me close. And also P5, I'm going to do the same. At the physical, I'm going to say like I want to use the user defined and not the default scaled value. So from here, I'm just going to insert the length value as 200 as well. That is the length, of course, is in meter. And also if I double click P6, I'm going to do the same. First, I need to set this to true. And from here, okay. And also P7, length is 200. I'm going to specify length 200. So I need to set this to true, then 200. And also this one here, P8. So if I select here P8, so the final, let me set here to true, and 200. And again, I need to select this one. I need to set the value here to the default value, so I'm going to select this as true. So P9, the value here is 300. And also let me finish this 2 here. So I need to click true, then insert the value, which is 150. And lastly, we have this P11. And we need to specify that we need to insert our own default value and not to use the scaled value. So I'm just going to select true. From here, I'm going to insert the value, which is 390 meter. So 390 meters, we are done. So now that we have our link properties set, the next thing that we need to do is to change the pipe material. Remember, by default, WaterGEMS is going to assign DI or ductile iron pipes. So what we need to do is to change the pipe material. Okay, so to do that, let me start with this link here, which is before. And if you go here, you can see by default the pipe material is DI pipe. So what we need to use is the plastic PVC pipe. With that, the only thing that we can do to change is to click at this one. So these are 3 dots. If I move this, you can see we have 3 dots here. If I click this, then this is the window that is going to display. So from here, what I can do is to click this plus value. So on the material library, what I can do is to click this plus button here and also click plus. So if I move this in and around this region, you can see we have several pipe material that we can use for our model. Okay, so this is the steel, and also let me find the PVC pipe. So this is the PVC. So from here, you can see our PVC pipe has this pipe material. So if you can check, this is the pipe name, and also this is the Young's modulus, Poisson ratio, and all those. The most important thing is the Hazen-Williams roughness coefficient, which is for our case 150. Okay, because we are using Hazen-Williams, this is very important. So for our case, this is the Hazen, is the C value. So from here, what I can do is to click select. Okay, so for now, the material has changed. So from DI pipe to PVC pipe. And not just that, even the C value of our Hazen-Williams coefficient has also changed from 130 to 150. Okay, so there is nothing here we can change. Let me close this, and also let me change this one. With this, also I want to use the PVC. Okay, and also this one. So this one I'll just change to steel pipe. So if I select here, you can see this is the steel, and these ones here are the its properties. I'll just select, then close, and again these ones here I can change as well. And again, this one is steel, not PVC, steel. So this one here, PVC. I want to change the PVC, the material PVC. Remember, the most important thing here, because we are using Hazen-Williams, the most important thing that is used in hydraulic calculations is not the pipe name, but it is this value here, which is 150. Okay, so with that, and also this one's here, I need to change to PVC, and also this one here, PVC, and this one here, I'll just maintain it the way it is, the DI pipe. Okay, so for pipe material, I think now we are done. Let's move to the next part. But one thing here that we haven't done is to insert the demand at these nodes here. So if you can see, at this junction here we have the users, and also at this junction and also this junction here we have the user. So we need to insert the demand values. So from here, what I can do is to double click this J8, and again let me scroll down. You can see, so this is the physical value, values, but what we are interested in is the demand. Okay, so the demand value. So if I select this demand collection, you can see we have this option here. So if I click these three dots here, you can see we have these small windows here appear. So from here, I'm going to specify the base demand. Okay, so the base demand, I'm going to enter here 1. Of course, it is 1 liters per second. The pattern, we are not going to touch anything on the pattern, because for now what we are dealing with is a steady state analysis and not the EPS or extended period simulation. So from here, I'm going to close this, and again I'm going to do the same on junction 11. If I click this, you can see we have this demand area here. So from here, what I can do is to click these three dots and again specify 1.2. Let me close this, and again this one here is 1 liters per second. So we need to specify the demand here as 1 liters per second. Of course, we touch nothing on patterns for now. So the base demand here is 1 liters per second, and this is what we want. So let me close this. So far, we have inserted all the required parameters on our network, from pipe length, elevation at each junction, and of course the elevation at our reservoir here. Everything now is done. So the next thing here is to run our model and see if we have any error. So before you run your model, as far as our WaterGEMS is concerned, what we need to do is to make sure that we don't have any error before we run our model. With that, the only thing that we can do, let me go back here to home. You can see we have two buttons here. So the first one is compute and the other one is validate. So we need to validate our model and let the software check if we have any error before we even run our model. So from here, what I can do is to click validate. If you can see, so far we don't have any problem, so no problem were found. So let me click OK, or you can even close. Now let me click compute. Okay, compute. So this is what we have. So if I can move this here, you can see we have here time spent and also the status. If it is balanced, it says yes. The number of trials, which are 2. So the number of trials that the software used to calculate our model. So we have 2 trials, and not just that, we have this flow supplied. Okay, so the total flow supplied from our source to these junctions here. Remember, these are the junctions that we insert our base demands. What our software does is simple. It just took the demand at this junction and also this one and find the total value. So if I can tell, here we had 1, so 1 plus 1.2 and 1, so it's like 3. So the same values that we have here. So the flow demanded from our source is 3.2. okay, and the flow stored is nothing because we don't have any storage tank at our model so far. Okay, but if I can check here, you can see we have something here. We need to check our model if it has all the required parameters like velocity, unit head losses, the flow, and even pressure. So for that, we are going to cover in the next part of this video.